All right, everyone, this is section 13.5. In this section, our goal here is to be able to solve triangles that have no right angle. So when we go to solve triangles that have no right angle, one of the ways we could do this is by using the law of sines. So we have the sine of angle A over the side length of A is supposed to be equal to the sine of angle B over the side length of B, and it's also equal to the sine of angle C over the side length of C. So in example 1, what we're going to do is find B and round to the nearest tenth. Okay, so we know that angle A is 37 degrees, and a little a, which is across from it, is a side length of 3. Big B, or angle B, is 68 degrees, and we don't know B, that's what we're trying to find. And we really don't need to know C, okay? Because according to the law of sines, we can set up a proportion. Because the sine of angle A, or 37 degrees, over the side length of A, which is 3, is supposed to be equal to the sine of B, which is 68 degrees, all over little b, or the side length of B, which we don't know and we're trying to figure out. So, since this is a proportion, we can cross multiply here. So we got the sine of 37 degrees times B is supposed to be equal to 3 sine 68 degrees. And again, we can get rid of sine 37 degrees by dividing it to solve for B. Okay, so we got B is equal to 3 sine 68 degrees all over the sine of 37 degrees. And we're going to have to round it to the tenth, so it's going to be about what we get in our calculator. So make sure it's in degree mode. And we're putting in there 3 sine 68 all over sine of 37. And it's about 4.6 when we round off there. So it's about 4.6. So B is about 4.6 units long. In our next example, we have a triangle ABC, and C is 170 degrees, angle B is 25 degrees, and little side length B is 15 degrees. And this one we don't have a picture, so go ahead and kind of draw one out. Okay, make one angle A, B, and C. Okay, or instead of having it like that, you could switch it around a little bit and do A, B, and C like that. Okay, it doesn't matter. But we're given A, B, and C as angles. And we have corresponding side lengths too, the little lowercase ones. But they told us angle C is 107 degrees. Angle B is 25 degrees. So let's put those in. Okay. And then side length B is 15. So across from angle B is side B. Okay. And we're supposed to solve the whole thing. So we've got to figure out the other missing angle and the other two missing sides. But if you look here, we have a side, an angle, and another angle. Okay? Or that's the same thing as angle, angle, side, which you've heard that before in geometry before. Angle, angle, side. Okay? So we're trying to figure out the other angle. Well, we know that the whole triangle has to be 180 degrees. And we already got two angles already. And 25 and 107 is 132 degrees. And if we subtract those, we get 48 degrees. So that's equal to angle A. So angle A is 48 degrees. So now that we know B, it's angle and side length, we could solve for the other side lengths A or C. Okay, because the sine of B, or angle B, or 25 degrees, all over side length B of 15, can equal the side, or sine of A, its angle, which was 48 degrees, all over little a. And we're trying to figure out little a. And when we, again, cross multiply, we're going to have 15 times the sine of 48 degrees all over the sine of 25 degrees. Okay, so A is going to be about, and if we go to the calculator, so 15 sine 48 over sine 25, and we get 26.4 if we round it off there. So 26.4, and that's units. So 26.4. And we could do the same thing to find the side length of C. Okay, so little a was 26.4. And if we try to figure out what C is, well, we're going to use B again. So sine of angle B all over side length B is equal to the sine of angle C, which is 107 degrees, all over the side length of little c, which we don't know yet. Again, cross multiply again. Okay, so we're going to get C is 15 sine of 107 degrees all over sine of 25 degrees. So C is going to be about, and then the calculator again. So we're doing 15 sine 107 all over sine 25. And we should get 33.9. So 33.9 units long. So there's our C. So here we have solved all three angles and all three sides of triangle ABC. So here's our answer for that question, example 2. So again, from geometry, you know that the measures of two sides in a non-included angle, side-side angle, do not necessarily define a unique triangle. So when given two sides in a non-included angle, one of the following will be true. No triangle exists. Exactly one triangle exists. Two triangles exist. And this is called the ambiguous case. So the ambiguous case of side-side angle, the acute triangle side. So consider a triangle in which A, B, and A, so angle A, are given. For the acute case, H is the height of the triangle. So H is equal to the side length B of sine of angle A. So if side length A is less than B and side length A is less than the height, then there is no solution. But if side length A is less than side length B and side length A is equal to the height, then there's one solution. If side length A is less than side length B, but side length A is greater than the height, there's two solutions to consider. And if A is greater than or equal to side length B, then there's exactly one solution. But we also have cases for when we have still side-side angle, but the obtuse side of it, or obtuse triangles. So consider a triangle in which side length A, B, and angle A are given, and angle A is an obtuse angle, then if side length A is less than or equal to side length B, there's no solution. And if side length A is greater than B, there's only one solution. So we're going to practice a few with these kind of triangles. So in example 3, we have to solve yet again another triangle that we don't have the picture of, so we're going to have to sketch it out. With angle A being 115 degrees, little side length A being 20, and side length B being 11. Okay, so let's think about this. We're given an angle and two sides here. Okay, so if I draw that out here, or kind of sketch what it might look like. Let's say A, B, and C. Okay, angle A is 115 degrees, side length A is 20, and B is 11. So here we have an angle side or side angle, which is what we just talked about. And we know that A is greater than B. So back up top here, and angle A is obtuse. So A is greater than B. Well, that's going to be this case. Since A is greater than B and A, the angle is obtuse, we're going to have one solution here in this example. So this should only have one solution. Or one triangle, I mean. Okay, so we know only one angle. That's angle A. And its side length was 20. And we know the side length of little b was 11. But we don't know anything about C's stuff. Okay? So we could first find out what the heck angle B is by the law of sines. So let's try to do sine of angle A, which we know is 115 degrees, all over side length A, which is 20. And it's trying to figure out what angle B is all over side length B, which is 11. Again, this is a proportion, so we can cross multiply here. So we got 11 sine of 25, or 115, sorry, equal to 20 sine B. Okay, then we're going to divide on both sides by 20. So I got the sine of B is equal to 11 sine 115 degrees all over 20. But now I need to take the inverse sine on both sides. So sine inverse on both sides. So we get that angle B is about, and if we go to the calculator here, sine inverse of 11 sine 115 all over 20. Oops. That is 29.9 if we round it up. So that's angle B, degrees. So you know all of A's stuff, all of B's stuff. And now we're trying to find C. But we know from earlier that A whole triangle is 180 degrees, and if we subtract out what we already know from it, so we add 115 and 29.9 and get 144.9, and we subtract those, we got 35.1 degrees being angle C. So 35.1 degrees. And lastly, we got to get side length C. Okay. So again, we could set up our proportion with the law of sines. So we know angle A is 115 degrees all over side length A. And we know C's angle now, which is 35.1. And we're trying to figure out side length C. Again, cross multiply. So we got 20 sine 35.1 all over sine of 115 degrees. So C is going to be about what we put in the calculator. So sine, or 20 sine 35.1 all over sine 115. And we get 12.7 if we round up. For side length C. And since we know all three angles and all three sides of the triangle, we've now solved for that triangle. All right, example 4. So we're going to draw a triangle again. Triangle ABC. It's a rough looking triangle. All right, and we know that angle A is 51 degrees. Side length A is 3.5. And side length B is 5. So again, we got a side-side angle situation going on. Excuse me. And our angle A is acute. Okay. So if we compare it up above with our chart, well, A is less than 5. Or A is less than B. Okay. And if we try to figure out what the height is, remember height of the triangle is B sine A. Okay. So in this case our little b is 5 sine of angle A, which is 51 degrees. So if we put that in the calculator, 5 sine 51, that's about 3.9. So even our side length A is less than our heights of the triangle. So we got side length A is less than B, and that side length A is less than our height of the triangle, and that corresponds with having no solution or no triangle possible. So this situation in example number 4 is not possible, or no solution. No such triangle exists that meet this criteria, so we cannot solve it all. So that one had no solution, or no triangle. In example 5, doing it again. Okay, we're going to try to solve triangle ABC with A being 40 degrees. Side length A being 13 and side length B being 16. Okay. So if we think about this, our angle A is acute. And we're still working with side angle. So we're going to compare it to our chart again. Well, in this case, our A is less than B. And now let's look at the height, which is B sine A. So 16 sine angle 40 degrees. So 16 sine 40 is about 10.3. So in this case, our A is greater than the height. So we're going to look for those criteria up above in the chart. So our acute angle, A is less than B, but side length A is greater than the height. So that has two solutions to it. So we're going to actually need two triangles in this case. Okay, so I'm going to split this up into two kind of triangles. And I'll call this triangle A or triangle 1. And this one triangle 2. Because there's two triangles from our given criteria. So if we focus over here with triangle 1, we're going to set up a proportion to see what the heck angle B is. So sine of 40 degrees from angle A all over side length A, which is 13, equals, we don't know angle B yet, all over side length B, which is 16. Still cross multiplying though. So we got sine B equals 16 sine 40 degrees all over 13. And we do need to take the inverse on both sides of sine to figure out the angle. So angle B, so sine inverse of (16 sine 40) all over, sine inverse alpha y equals 16 sine 40 all over 13. Okay, and if we round that off, that is 52.3. Okay, it's about 52.3 degrees. All right, so there's our angle B. Now in order to get angle C, well, we know our entire triangle again is 180, and we subtract it from what we know, so 40 degrees plus 52.3 degrees, that is 92.3. And if we subtract those, we get 87.7 degrees. So that is C. All right, and now we're just trying to figure out what side length C is. So we're going to try to figure that out. Now that we know angle C, which is 87.7 degrees, we're going to cross multiply again. So we got that C is 13 sine 87.7 degrees all over sine of 40 degrees. So if we put that in the calculator, we get 20.2 if we round. So we fill in what we know now. Here's our first triangle all the way solved. But we still have to deal with our second triangle. Okay, so angle A is still 40 degrees. Little side length A is 13, and little side length B is 16. And we still don't know angle C and side length C. Okay, so from on the other side, when we did sine inverse to get angle B, we got 52.3 degrees. But we could do 180 minus 52.3 degrees to get that obtuse angle for our second case of triangle. Okay, so 180 minus 52.3 is 127.7 degrees. Could be angle B. Because if we still use the same 52.3 degrees, we would still have the same kind of result as we did in triangle 1. Okay, and now that we know A and B as angles, we can find angle C, because 180 minus the two angles that we know, 40 degrees plus 127.7 degrees is 167.7 degrees. And if we subtract those, we get 12.3. So that's our angle C. And lastly, we can get side length C by doing our last lines. So sine 40 degrees over side length A, which is 13. The sine of angle C, which is 12.3 degrees, all over side length C. We're still going to cross multiply though. And we're going to get 13 sine of 12.3 degrees all over the sine of 40 degrees. So C is going to be about what we put in the calculator. So alpha y equals, and we're doing 13 sine 12.3 all over sine of 40. And we get 4.3 when we round. So little side length C is 4.3. Angle B was 127.7 degrees. And angle C was 12.3 degrees. So again, in triangle 2, our second case of triangle, given our criteria, here's how we solved for all three angles and all three sides to solve that second triangle. The last thing we're going to talk about here is the area of a triangle. And we have three different formulas we could use depending on what kind of information that we're given. And it's always using 2 out of the 3 side lengths and some kind of angle that we're given, and we're going to take its sine. So in example 6 here, our last example, find the area of the triangle with the measure of angle A. So we know angle A is 33 degrees. Angle B is 47 degrees. and side length B is 14. Round angle measures to the nearest degree, and side measures to the nearest tenth. All right. So let's talk about what we're even given. We're given two angles, A and B, and then one side, which was B. Okay. We could either use the formula that has the sine of A, or B. We could really just use any formula we want to. We just got to pick out what information we have and what do we have to get yet. Okay, so let's say I want to use the last one because I know that, let's see here. I see. Okay. So I know that I have 2 out of the 3 angles, so I'm trying to figure out what the heck angle C is. So I know the whole triangle is 180, and if I sum up my 2 angles that I know, 33 and 47, that is 80. So I know 100 minus 80 is 100 degrees. So I know angle C is 100 degrees. But I at least need one more side figured out in order to use my area formula. So let's say I want to find side C, for example. Okay, so if I want to figure out what side C is, well, I know its angle now of C, which is 100 degrees. And I know angle B, which was 47 degrees, and its side length was 14. So if I cross multiply that, I'm going to get C is equal to the 14 times sine of 100 degrees all over sine of 47 degrees. So C is going to be about, and when we put that in the calculator, so 14 sine 100 all over sine of 47. And I should get 18.9 when I round up. So here's side C, 18.9. So let's use what I got. I got 1/2 in there, and I'm going to use B and side length C because it's the only 2 side lengths I know. And I'm going to use the sine of A because that uses side lengths B and C. Okay. So if I plug in what I know, I got 1/2 times sine length B, which is 14, times sine length C, which we just figured out was 18.9, times the sine of angle A, which is 33 degrees. And we could straight up plug that all in the calculator. Okay, so 1/2. Oops. And then we're multiplying by B, which is 14, and C, which is 18.9, times the sine of 33 degrees. And we get about 72.1. And we don't have any units, so I'm just going to make it units squared because we're working in area. So 72.1 units squared. Now, if you figured out what side length A was and used a different formula, you will end up with an answer that's kind of close to the 72.1 units squared. It's just from all the rounding that we do when we find the other side lengths, then it might be off by a couple tenths of a unit.